Welcome everybody. Today I wanted to do a little bit of a universe tour for you to get an idea of the scale of the universe. And to do that, I'm going to be using a program called Open Space Project. So this is a program that can be downloaded free of charge for Windows and Macintosh and Linux machines. You can visit it at openspaceproject.org. And this is a project that's funded partially by NASA to bring you data from the universe. So everything we're going to see in this program today is from real data measured from telescopes and other observations. So let's go ahead and get started. So here's our planet Earth, and we can navigate around here and look at the scale of our Earth. It has some lines on here. One of the lines that we see is this yellow line, which is the orbit of a low Earth orbiting satellite. So you can see how close the satellites are to the surface of the Earth. And most human beings in the space program have never been further from that point. In fact, there's only a handful of astronauts that have been to the moon, and for the most part, we haven't left low Earth orbit. So that gives you an idea of the scale of our solar system, or at least our planet, relative to the solar system. And you can see some land masses on here. There's Europe and Africa. We can see Asia over there. So that gives you an idea of the scale of the universe. Now what I'm going to do is I'm going to start to zoom out. And as we zoom out, we're going to see the planets and the stars and galaxies as we go. I'm going to do this quickly. We're going to be traveling at vast multiples of the speed of light, but that's something cool that I can do in a program. So here we go. So we start zooming out here, and the first thing we notice is we see the orbits of the moon and some of the other planets. So there's our moon just passing, and very quickly, we're only about 1 lunar distance away, 2 lunar distances away, and now we start to see the orbits of the other planets. There's Mars, Venus and Mercury, and here comes Jupiter. And we're zooming out, and I want you to notice that we don't see the background stars moving at all. And in fact, as we move out here, you're going to see the sun in just a second. This is the afterglow of our star. As we move away from our star, we only see the stars fixed in the sky. So the constellations that you're used to seeing from the planet Earth are the exact same constellations that you would see from Pluto or from any place else, because they're so far away. Now as we move out here, when we get to about 3 light years away, you start to notice the other stars moving. Just off to our left, that's Alpha Centauri, some of the other nearby stars. And here we are at about 30 light years away. Now we really start cruising past all of the stars in our galaxy. All the points you see fixed now in the background are galaxies themselves. Each point is 100 billion stars. And as we move out of our galaxy, we'll leave these stars behind, and we'll see the shape of our galaxy. The Milky Way galaxy contains about 100 billion stars, and now every point of light that you see in the background is another galaxy representing hundreds of billions of stars. And as we move even further away, you'll start to see the galaxies start to move away. And here we are getting out to the very edges of the observable universe, and we see the structure of the universe in the galaxy clusters that exist. We're going to keep moving out a little bit until finally we reach the edge of the observable universe, something known as the cosmic microwave background. Now, this is the afterglow of the origin of the universe and represents the beginning of the space that we live in. Now, we can't see past this because it has taken the entire age of the universe for the light from this event to reach us. So this is what we're seeing when we look out at the cosmic microwave background. And nothing out beyond the cosmic microwave background is observable because it just hasn't had time to reach us yet. And as far as we know, the universe is infinite in extent, but we're limited to what we can see by how much time has elapsed since it began. So I'm going to go ahead and zoom in again here. We'll zoom in past the cosmic microwave background. And as we enter that, we enter what's known as the observable universe. And we can see the positions of the galaxies and the clusters of galaxies. And we zoom in to our local galaxy, the Milky Way. And we live about 2/3 out in the Milky Way's arms, and we zoom in to our local group of stars, which includes our sun, and then finally the planets that orbit the sun. Now, to give you an idea of the distances involved here, it takes about 8 minutes for light to travel from the Earth to the sun. It takes it about an hour for light to travel across the solar system. It takes a few seconds for light to travel between Earth and the Moon. So we'll go ahead and zoom in here back to where every single human being you've ever known has ever lived on the planet Earth. So I hope that gives you some idea of the scale of the universe. I've got another video for you to watch that is going to show you the scales of different objects within the universe. And this is the first thing I'd like you to try to fit inside of your head for this class, is the sheer vastness of space. And I look forward to seeing you next time.